Hello and welcome guys to EduCeption. Today we begin with similarity. Now the complete chapter of similarity will be divided into 3 videos and I hope after watching all the 3 videos you understand similarity easily. This is the first video and in this video we will be talking about the basics of similarity and all the theorems that you need to know in similarity. So if you like our video, do give it a thumbs up, subscribe to our channel EduCeption and share this video with all your friends. Without further ado, let's begin. First and foremost, let's check out the definition of similarity. Figures which have exactly the same shape but not necessarily the same size are said to be similar. I hope that's easy to understand. Figures which have exactly the same shape but not necessarily the same size are said to be similar to each other, and this property is called similarity. Okay, but what actually is similarity? Now similarity is a part of geometry where we deal with figures which have exactly the same shape. We don't care about the sizes as long as the shapes of the figures are exactly the same. Let me give you a few examples. Say I have 2 figures, figure A and figure B. I hope you can figure out what these figures are. Figure A is a circle and figure B is also a circle. But figure A is much smaller to figure B. So, can I say that figure A is similar to figure B? Yes, I can say that these 2 figures are similar to each other. How? You can see both of them are circles and each and every circle has the same shape. Okay? So, the shape of figure A and the shape of figure B is exactly the same. The size may be different, but the shape is exactly the same. Both of them are circles. So I can say that figure A is similar to figure B. Okay? How do we denote that? We write circle A is similar to circle B. Okay? You can see that I use this sign. This is the sign of similarity and it is read as is similar to. So whenever you are saying that 2 figures are similar to each other, you will write it this way. Circle A is similar to circle B using this sign. Okay. Now let's move on to the next example. Say I have 3 figures. This and this. Say figure X, Y and Z. Okay. Can I say that figure X, Y and Z are similar to each other? Yes, over here also I can say that figure X, Y and Z are similar to each other because you can see the shape of figure X, Y and Z is same. All the 3 of them are squares. Okay. So figure X, figure Y and figure Z are similar to each other. The sizes may be different, but as long as the shape is exactly the same, the figures are said to be similar. So basically figure X is similar to figure Y and similar to figure Z. Now let's move on to the next example. Say I have the letter F. This is capital F and this is small f. Can I say that capital F is similar to small f? I can't say that both the figures are similar. Why? Because you can see the shape of both the figures are totally different. Okay? They may both be F's, but the shape is totally different. So capital F is not similar to small f. Okay? I hope you understand this. Now, the big question comes, why do we study similarity and what is the need of it? Now say I want to construct a huge building. So I will not just start constructing the building first. First I will construct the model of a building which is much smaller to the actual building, and using that model I'll construct the actual building. So what does similarity help us to do? Similarity helps us to shrink that huge building into a small model without making any geometrical alterations, so that using that model I can create the actual building. So if we want to compress the size of a geometrical figure without losing its shape, we will use similarity, and that is why we study similarity. Okay. In your syllabus, you will have to study the similarity of triangles. Okay. And to study about similarity of triangles, you will have to study about 3 axioms, and we will begin with the 3 axioms now. Before beginning with the axioms, let me talk about similarity of triangles. Assume that you have 2 triangles, say triangle A, B, C, and say triangle P, Q, R, and let both these triangles be similar to each other. That means triangle A, B, C is similar to triangle P, Q, R. Okay. Now, what does this mean? Whenever we say that 2 triangles are similar to each other, we can deduce 2 things. First of all, we can deduce that the corresponding angles of both the triangles will be exactly the same. Let me repeat it once more. The corresponding angles of both the triangles will be exactly the same. That means angle A will be equal to angle P, angle B will be equal to angle Q, and angle C will be equal to angle R. Okay, let me write it down. Angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. Now you may ask me, how do I find the corresponding angles? Whenever we write triangle ABC is similar to triangle PQR, we write it according as the corresponding sides. CAP, AP, BQ, BQ, CR, CR. Okay, so that is how we write the similarity sign, so that we can easily understand the corresponding sides and corresponding angles. Secondly, we can deduce that the corresponding sides will be in the same ratio. Okay, what does that mean? That means that AB divided by PQ will be equal to BC divided by QR will be equal to CA divided by RP. Okay, so the ratio of the corresponding sides will be the same, or we can also say the corresponding sides will be in proportion. And one more thing over here, if both these properties are satisfied for 2 triangles, then we can say that both the triangles are similar to each other. That is what we will learn in the axioms that will follow. Okay, so now let's begin with the axioms. Beginning with the first axiom, we have AA rule or angle rule. It states that if 2 angles of a triangle are equal to 2 angles of another triangle, then the 2 triangles are similar. I hope it's easy to understand. If we have 2 triangles, and for each of the triangles, if 2 angles are same, then we can say that both the triangles are similar to each other. Imagine that you have 2 triangles, say triangle A, B, C, and triangle X, Y, Z. Okay. Now imagine that angle A over here is equal to angle X over here, and angle B over here is equal to angle Y over here. If this occurs, using the AA rule, that means the angle rule, we can write that triangle ABC is similar to triangle XYZ. Okay, so I hope you understand that if in 2 triangles we have 2 angles same, then we can say that both the triangles are similar to each other. Okay, now we'll move on to the next axiom. Moving on to the second axiom, which is Sas rule, that means the side angle side rule. It states that if one angle of a triangle is equal to one angle of another triangle and the sides including these angles are proportional, then the two triangles are similar. What does this mean? Imagine you have two triangles, triangle ABC and triangle XYZ. In these two triangles, say angle A is equal to angle X, number 1, angle A is equal to angle X, and the side containing these angles are proportional to each other. Sides containing the angle, what does that mean? Say we have angle A over here, then the side containing angle A are the side AB and the side AC. And in this triangle, the sides containing angle X are the sides XY and the side XZ. Okay? So, these two sides are proportional to each other. That means AB divided by XY is equal to AC divided by XZ. Okay? If both the things follow, then we can say that the triangle ABC is similar to triangle XYZ using the Sas rule. Let me explain it to you once more. Imagine that you have two triangles, say triangle ABC and triangle XYZ. In both the triangles, say one angle of each of the triangle are equal. Angle A is equal to angle X over here. And the side containing these angles are proportional. That means AB divided by XY will be equal to AC divided by XZ. Then using the Sas rule, we can say that both the triangles are similar to each other. Now, we have an example over here, and using this example, we can easily understand Sas rule. What is that? We have construct two triangles DEF and PQR using angle D is equal to 60 degrees and angle P is equal to 60 degrees. With sides D is equal to 3 cm, DF is equal to 4 cm, PQ is equal to 6 cm and PR is equal to 8 cm. Are the two triangles similar? Let's construct the triangles. First we have triangle DEF. DEF. In the triangle DEF, angle D is equal to 60 degrees. The side DE is equal to 3 cm and the side DF is equal to 4 cm. This is our first triangle, and the second triangle is PQR. And in this triangle, angle P is equal to 60 degree. The side PQ is equal to 6 cm and the side PR is equal to 8 cm. Okay. Now we have been asked that are these two triangles similar or not. Let's check them out. We can see that angle D is equal to angle P. Both of them are 60 degrees. So number 1, angle D is equal to angle P because both of them are 60 degrees. Now we will check the sides which contain the angles. Number 2. First let's check DE by PQ. So DE by PQ, it is 3 cm divided by 6 cm, which is half. So the ratio is half. Then we have DF divided by PR. So DF divided by PR, which is 4 divided by 8, which is also half. Therefore, we can say that DE by PQ is equal to DF by PR. That means the side containing the angles are proportional to each other. So using the Sas rule, we can say that triangle DEF is similar to triangle PQR. Okay. Now we'll move on to the next axiom. Moving on to the third axiom, we have the Sss rule, which is the side rule. What does it state? It states that if the three sides of one triangle are proportional to the three sides of another triangle, then the two triangles are similar. Easy to understand? Imagine that you have two triangles, triangle ABC and triangle XYZ. Now in both the triangles, the three sides are proportional. That means AB divided by XY is equal to BC divided by YZ is equal to CA divided by ZX. Then we can say, using the Sss rule, that triangle ABC is similar to triangle XYZ. I'll explain it to you once more. Imagine you have two triangles, triangle ABC and triangle XYZ. In both the triangles, the three sides are proportional. That means AB by XY is equal to BC by YZ is equal to CA by ZX. Then using the Sss rule, that is the side rule, we can say that the triangle ABC is similar to triangle XYZ. Now we have a sum over here, and using that sum we can understand the application of Sss rule. Okay, what do we have? We have, draw two triangles DEF and PQR, DEF and PQR, such that DE is equal to 2 cm, EF is equal to 3 cm and FD is equal to 2.5 cm, and PQ is equal to 4 cm, QR is equal to 6 cm and RP is equal to 5 cm. So that triangle DEF is similar to triangle PQR. We'll use the Sss rule. Let's check whether the three sides are proportional or not. First we have DE divided by PQ, which is 2 cm divided by 4 cm, which is half. Then we have EF divided by QR, which is 3 cm divided by 6 cm, which is half. Then we have FD divided by RP, which is 2.5 cm divided by 5 cm, which is also half. So we can see that the three sides are proportional. That means DE by PQ is equal to EF by QR is equal to FD by RP. And by using the Sss rule, we can say that triangle DEF is similar to triangle PQR. Okay. Now, whenever in the sums we are asked to prove the similarity of two triangles, we will use these three axioms that I just taught you. Now we'll move on to the next thing. The next thing is basic proportionality theorem, or BPT. It states that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. What does that mean? Imagine that you have a triangle ABC and you have a line drawn parallel to one side of the triangle. Say I have taken the side BC and I am drawing a line parallel to BC. Okay, and the line intersects the other two sides in distinct points. We have two distinct points, one over here, one over here. Let's call this D and let's call this E. Then the other two sides are divided in the same ratio. That means the ratio of division done by this line is same for both the sides, which basically means that AD divided by DB is equal to AE divided by EC. So the ratio of division is same, and this is what basic proportionality theorem teaches us. Now the proof is not in your syllabus, so no need to do the proof, but there are a few deductions that we need to do. We will do two deductions. Let's do them. First of all, we will have AD divided by AB is equal to AE divided by AC. Okay. Now imagine that basic proportionality theorem holds for this triangle. That means this is true. I'll take the reciprocal, which is DB divided by AD is equal to EC divided by AE. Okay. Now I'll add 1 to both the sides. Therefore DB divided by AD plus 1 is equal to EC divided by AE plus 1. Let's move over here and do the LCM. Therefore, DB plus AD divided by AD is equal to EC plus AE divided by AE. Okay. Now what is DB plus AD? You can see in the figure that AD plus DB will equal to the full length, which is AB. Therefore, AB divided by AD is equal to, then we have EC plus AE. You can see AE plus EC over here will give the full length. AC is equal to AC divided by AE. Now we'll take the reciprocal again. Then we will get AD divided by AB is equal to AE divided by AC. So this is what we wanted to prove, and we have proved this. Now we'll move on to the second deduction. The second deduction is DB divided by AB is equal to EC divided by AC. Let's do this. We will do it the same way. If basic proportionality theorem holds, this will be true. Now I'll add 1 to both the sides. Therefore, AD divided by DB plus 1 is equal to AE divided by EC plus 1. Let's take the LCM. We will have AD plus DB divided by DB is equal to AE plus EC divided by EC. Let's move over here. We can see that AD plus DB is equal to AB. Therefore, AB divided by DB is equal to, we see AE plus EC will equal AC. So AC divided by EC, and then we will take the reciprocal. What do we get? We will get DB divided by AB is equal to EC divided by AC, and this is what we wanted to prove. Now in basic proportionality theorem, you have to remember all these three results, 1, 2 and 3, and we will make these use of results in the sums that we will solve. Also, you need to know the converse of basic proportionality theorem. What does it state? It states, if this is true, that means if a line segment divides two sides of a triangle in equal ratio, then the line segment will be parallel to the other side. It is simply the converse, that means the ulta. If this is true, then the line segment will be parallel to the other side. Okay. Now we'll move on to the final thing, which is area of similar triangles. Areas of similar triangles. The ratio of the areas of two similar triangles is equal to the ratio of the squares of their corresponding sides. What does this mean? Imagine you have two similar triangles. Say triangle ABC is similar to triangle PQR. Okay. What did I tell you before? If two triangles are similar, their corresponding sides will be in proportion. That means AB divided by PQ is equal to BC divided by QR is equal to CA by RP. Okay. Now let's check this statement out once more. The ratio of the areas of two similar triangles. We have two similar triangles. Let's take the ratio of their areas. That means area of triangle ABC by area of triangle PQR. Okay. Now this is equal to the ratio of the squares of their corresponding sides. We have the corresponding sides, that means this will be equal to AB square divided by PQ square equal to BC square by QR square is equal to CA square by RP square. Okay, so this is the thing relating to areas of similar triangles. Area of triangle ABC divided by area of triangle PQR will be equal to AB square by PQ square equal to BC square by QR square equal to CA square divided by RP square. That means ratio of the areas of two similar triangles is equal to the ratio of the squares of their corresponding sides. I hope you understand this. It's very easy. Now, this is the last thing of the theory you need to know before solving the sums of similarity. In the second part, that means the next video, I'll solve some sums based on similarity and all the theory that we did in this video. So do watch the next video, and until that next video, this is Rishi on behalf of EduCeption signing off.